All right, we're going to talk about synthetic division. And so you guys have probably heard of long division, or maybe remember that from when you were in elementary school. Well, now we're not going to do long division. We are going to do what's called synthetic division. And what synthetic division does is a faster way to divide, and it only uses the numbers attached to the variables. So you don't have to get confused about the variables. So what we're going to do is say we're given the same problem, 2x cubed minus 3x squared minus 18x minus 8. And we want to see, hey, does this go in evenly or not? Does x plus 1, is that a factor? Does it go in evenly? Meaning, is when x equals -1 a solution? Is this going to cross the x-axis at -1? So what we can do is use synthetic division to find that answer quickly. So how we would do this is whatever they want us to divide by, so in this case x plus 1, we're going to take that x plus 1 and we're going to set it equal to 0. And we need to solve because we need to figure out, oh, okay, so after I subtract 1 from both sides, I get that x equals -1. So what I'm doing is I'm checking to see, is x actually equal to -1 in this equation? And if so, it's going to give me what's called a depressed equation, which will help me find the other factors or the other roots of our cubic function. All right, so what do I do with this x equals -1? So after I take what we're supposed to divide by, and I set it equal to 0 and solve, I'm going to take that -1 and I'm going to put this in a backwards L. So I'm going to kind of leave that off to the side because that is what I'm dividing by. Now, what I need to do in the top row of numbers is I'm going to write out every number that I have attached to a variable, including the constant at the end. So for example, I have a 2x cubed, so I'm going to write a 2. I have a minus 3x squared, so I'm going to leave a space and write -3. And I have minus 18x, so I'm going to write minus 18. And then I have this minus 8 as my constant at the end. So I'm going to just leave a gap for each number. Now I'm going to leave some space here, and this is just the process that you're going to have to memorize. So we're going to drop down our first term, so we're going to bring that 2 down, and every number that's underneath this line is going to be multiplied by the number in this backwards L, by what we're dividing by. So I'm going to multiply -1 times 2. Well, that gives me -2. And then I'm going to just add straight down. So what do I get when I combine a -3 and a -2? Well, that's a -5. And then I'm going to take -1 times -5. And that's going to be a +5 because negative times negative is positive. What happens when I combine a -18 with a +5? Well, I get a -13. Then I'm going to bring this -1 and multiply that to -13. So again, negative times negative is positive. So this becomes +13. Finally, when I combine a +8, or a -8, sorry, with a +13, I get a +5. Now what we were hoping to see is that if this is a solution, meaning if this does divide by x plus 1 evenly, then I should have gotten a remainder of 0 here. So because I did not get a remainder of 0, we would say that this is not a factor. So x plus 1 is not a factor, meaning it doesn't go into it evenly. It's kind of like if I said, hey, what's 20 divided by 5? You would say, oh, 4. Well, why? Because 5 goes into 20 4 times evenly. But if I said, what's 20 divided by 6? It would not go in evenly. You would have to give me a decimal or a fraction. And so this is the same thing here. It doesn't go in evenly, so we don't get a remainder of 0. If I divided 20 by 6, I would get 3 with a remainder of 2. It's no different here. So what we're going to do is now see an example where it does actually go in evenly, and it'll give us more practice so we can kind of see what that looks like. So, oh, I gotta borrow this. Thank you. I like your hair, looks good. So what we're going to do now is check the same problem but divide by 2x plus 1. So remember, we're going to take what's inside our parentheses, 2x plus 1. We're going to set it equal to 0, and then we need to solve. So after I subtract 1 from both sides, I get that 2x equals a -1. And then after I divide by 2, I am checking everywhere where x equals a -1/2. So remember, that -1/2, that is what's going to go inside this backwards L. Meaning that is the number that I'm going to multiply to every term underneath that division bar, so underneath this line. Now remember, we have to write the first number of each term on our line. So I have 2x to the third minus 3x squared minus 18x minus 8. So I have my 4 terms. Now what happened if I had like an x to the third and this was an x? Well, I'd be missing the x squared term. So you'd have to have a filler in there of 0. And so we'll do a couple examples like that later. So every number needs to have a spot, a position, a place, a placeholder. So what we do first is we drop down our first term. So I'm going to drop down our 2. And I'm going to multiply negative 1/2 times a positive 2. Well, negative times positive is negative. And half of 2 is 1. So this is negative 1. What happens when I combine these together? I get a negative 4. A negative times negative, again, is positive. Half of 4 is 2, so this is a positive 2. What happens when I combine these together? I get a negative 16. A negative 1/2 times a negative 16 is going to give me a positive 8. And when I add those together, I get 0. So I do get a remainder of 0. This is what we want to see. Meaning that 2x to the third minus 3x squared minus 18x minus 8 is perfectly divided by 2x plus 1 with no remainders. It goes into it evenly. Now you might be asking, okay, well, what happens when I divide it by 2x plus 1? What do I get? Well, actually what you get is this right here. So if I took it and I had 2x plus 1 and I divided, what I have left over is what's called the depressed equation. If I started with an x to the third and I divided out an x, that means this is going to be a 2x to the second. So each exponent is going to drop 1. It's called a depressed equation. I say that it's sad because it's smaller. Then this is going to be minus 4x and then minus 16. And what would happen is if you were to distribute this 2x plus 1 to each term, you would get back to your original. What we would do in the future then is knowing that x does equal negative 1/2, that's what we just checked because I got a remainder of 0, I would then factor from here to find our other 2 solutions. So one of our 3 solutions is negative 1/2, that's what we checked. The other 2 solutions are going to come from this trinomial. And so we can factor or do synthetic division one more time to see what those answers are going to be. So yes, this is our answer. 2x plus 1 is a factor of our original function.